Okay, hello Calc 2 students. I've got a few questions about the practice test, so I wanted to go over all these problems with you. In case anybody had trouble with any of them, I'm going to just go ahead and do them all. Beginning with number 1. A solid lies between planes perpendicular to the x-axis at 0 and 9. The cross sections perpendicular to the axis on the interval 0 to 9 are squares with diagonals that run from the parabola y equals negative 2 root x to the parabola positive 2 root x. Find the volume of the solid. Alright. I got to draw a picture to figure out what's going on. That's kind of what I'd have to do here. So we have the parabola positive 2 root x and negative 2 root x. And the planes perpendicular to the x-axis at x equals 0 and at x equals 9. Okay, so we'll say this is at 9, this is obviously at 0. And we have a solid that has squares as the cross section, and we have the diagonals of the squares, not the side of the square, but the diagonal of the square running between those two curves. So if we can find the length of that diagonal of the square, I think we would be in good shape. So imagine this shape looks something like this. Okay, and you have this diagonal running right here. And then, so that's the cross-sectional area. And then we're going to look at it as very, very thin square prism. Okay, so this is dx, this thickness, this really thin thickness right here. And so if we can get the area of that square as a function of x, and then integrate that area over the entire distance that it runs, that it is extended on the x-axis 0 to 9 of that area function, then it's like area times a length, which gives you volume. And that's what the volume is going to be. So first I got to get a function for the area of the square. So this is the diagonal length. So what is that diagonal length? It's the distance from here to here. So it's the distance from this curve to this curve. And what is that distance? It's the difference between that and that. So the diagonal length is equal to 2 square root x minus negative 2 square root x, which is going to be plus plus. Let's add them together, you get 4 square root x. That's the diagonal length. Now, how do we get from diagonal length to area? Let me draw a picture of that. Okay, let's say we have a square right here. Let me draw a better square. Let me just draw a regular flat square. Okay, and I have this diagonal right here. And this is 4 square root x. Well, if I could get a side length from that, maybe I could get from there to a side length. Then the square of the side length is the area of the square. So I'm going to try to go that way. We could use trig ratios to get the side length here. Since this has to be a 45, 45, 90 triangle, since it's an isosceles right triangle, since it's a square. Or I could use the Pythagorean Theorem with this being a and this also being a, since they're equal, because it's a square. I think I'm going to go that way. I'm going to say a squared plus a squared equals, so it's usually a squared plus b squared equals c squared, but the sides are the same, so I'm just going to call them both a, equals the hypotenuse 4 squared x squared. So that becomes 2a squared equals 16x divided by 2a squared equals 8x. So a equals plus or minus, but I'm just going to say plus the square root of 8x, which is 2 root 2x. And so now the area of that square is the square of the side length. That's the side length. So the area is the square of that. So square root 2x, which is 4 times 2 times x, which is 8x. And now integrate that. That's the area. So integrate the area over that full 0 to 9 length. And that's going to be 8x squared over 2, which is 4x squared from 0 to 9, which is going to be 4 times 9 squared minus 4 times 0 squared. Well, that's just 0. So it's 4 times 81. 4 times 1 is 4. 4 times 8 is 32. So 324 is the volume of that solid. And I did type it in already. And did get it right. 324. Moving on to number 2. Find the volume of the solid generated by revolving the shaded region about the x-axis. Okay then. About the x-axis. All right, I'm going to make more of a picture here. So this is revolving this thing around the x-axis. All right, so the disk method seems to be a good way to go here. Imagine a disk right here. So the cross-sectional area of this is a disk. It's a circle. And the area of that circle is pi r squared, where what is r? So the area of the circle is pi r squared, where r in this case is the distance right here. And that distance is the distance up to that line. I'm going to go ahead and say this is 2y equals 12 minus 3x. Y equals 6 minus 3 halves x. So that radius is that height, 6 minus 3 halves x. So the area of that circle is pi times 6 minus 3 halves x squared. Okay? And we're going to, the volume of that whole shape is, so that circle is actually a disk of infinitely thin thickness. Okay, so that's going to be dx, that little thickness. So the area of that circle times dx gives me the volume of that little tiny cylinder, a little tiny disk. And so if I have an infinite number of those with an integral, it's the integral from 0 to what? Well, I actually need to know where this thing crosses the x-axis. Where does this thing cross the x-axis? So we started at 0 and we end it there. What is there? Well, I need to find the x-intercept of this. Find the x-intercept of that by plugging in 0 for y. Plug in 0 for y, that term goes away. And I get 3x equals 12 divided by 3. X equals 4. So that is 4. So I'm integrating from 0 to 4. I'm going to bring the pi outside. And it's going to be 6 minus 3 halves x squared dx. Alright, I think, what do I want to do there? Do I want to go ahead and expand that? I feel like I probably do. 6 minus 3 halves x times 6 minus 3 halves x. That's going to be 36 minus 6. 3 is 18 over 2, 9. X minus 9x plus 9/4 x squared. So that's 36 minus 18x plus 9/4 x squared. So it's the integral of that. So 4 with pi. So that's going to be 36x minus 18x squared over 2. I'm just going to go ahead and write that as 9x squared plus 9/4 x cubed over 3. I might have to figure that out. 9/4 x cubed over 3. So that's times a third. So that cancels that, and that becomes 3. So 3/4. So plus 3/4 x cubed. 0 to 4. And so just let me leave the pi out here for a second. 36 times 4 minus 9 times 16 plus 3/4 times 64 minus, well, all that, when I plug 0 in, I just get 0. So let me see if I can multiply all that and add it and use my calculator. 36 times 4 minus 9 times 16 plus 3/4 times 64. I get 48. So the answer should be 48 pi. Let me type it in and make sure that is correct. 48 pi. Come on, baby. Yes, sir. All right, green check mark. Next question. Okay, number 3. We are finding the volume of this solid that's revolved around the x-axis using the shell method. All right, so revolving this around the x-axis. Just trying to get me a picture. This is some really bad drawing so far, but we'll see if we can do a little better. Okay. We're going to use cylindrical shells. So, like here is going to be this cylindrical shell. Okay. All right, here's a cylindrical shell. All right, when we unravel that cylindrical shell, it is a rectangle. When we unroll it, it's a rectangle with a really small thickness. Okay. All right. The height of that rectangle is this. This is the height of that rectangle. And the height of that rectangle is going to be 6. It's going to be the height right here. It's going to be 6 minus this curve's function right here. 6 minus 2y squared. Which becomes 6 minus 6 cancels out, and then that becomes positive, so 2y squared is the height then. All right, the length is the circumference of that cylinder. And the circumference of that cylinder, okay, there's r, is 2 pi r. And what is r? R is this distance right here, which is just the y coordinate of that curve. So in other words, it's 2 pi y. Okay. Now everything is in y is a function of y so far. So I think that's a good thing. And what is that thickness? What is this thickness right here? It's like this little thickness right here. What is that little thickness right there? It's dy. It's a little change on the y-axis right there. So that thickness is dy. Okay, so the volume then is the integral of the area of this rectangular face, which is the length times width, which is 2 pi y, times the width or height or whatever you want to call it, which is, I meant to put y, times 2y squared dy as we integrate from here to here. So the cylindrical shells are going this way, and they stop there. And that stops at the square root of 3, so they integrate it from 0 to the square root of 3. Alright, so that's going to become the integral from 0 to square root of 3. I'm going to factor out my 2. Actually, I'm going to factor out a 4. Give a little bit more room. I'm going to factor out a 4 and a pi because of that 2 right there and that 2 right there. And I've got a y cubed dy. And so that becomes 4 pi y cubed, sorry, y to the 4th over 4. That cancels that, which is just pi y to the 4th as we integrate from 0 to square root of 3, which becomes pi times root 3 to the 4th minus 0 to the 4th. So the square root of 3 to the 4th, that's going to be the square root of 3 times the square root of 3 times the square root of 3 times the square root of 3, and that's going to be 3, and that's going to be 3, and then together that makes 9. So that's going to be 9 pi, I do believe. I believe it's 9 pi. Let's plug that in and see. Nine pi. Correct. Yay, green check mark. Next question. Number 4. Again, the shell method, revolving the shaded region about the y-axis. Okay. So I'm revolving this thing about the y-axis. Okay. And I am going to make myself a cylindrical shell, just a random cylindrical shell, like this. Okay, and again, when we unravel that cylinder, it makes a rectangle with a little bit of thickness, so like a infinitely thin rectangular prism. And the height of that rectangle is this height right here. So what is that height? The distance from there to there is just the height of this guy. And the height of that guy is y equals 2 square root of x squared plus 1. So I think I'm integrating dx here because it's going to be a little bit of thickness on that, an infinitesimally small thickness on that cylinder. So I'm integrating dx. So I want everything to be in terms of x. So the height is 2 square root of x squared plus 1. And the length is the circumference of that sphere. And if I have a radius that goes from here to here, that is going to be just the x coordinate of this point, right? If the radius is this, then it's just whatever this x coordinate is, so it's just x. So it's 2 pi r, but r in this case is going to be x, so 2 pi x, because x is the radius here. And I'm integrating this from 0 to here, from 0 to square root 3. So it's the integral of 2 pi x times 2 square root of x squared plus 1 dx from 0 to square root 3. Okay, so I'm going to bring out a 4 pi. Then I've got x square root of x squared plus 1 dx. Now I'm thinking u substitution. Is that what you're thinking? That's what I'm thinking. Why am I thinking that? I'm thinking that because if I make u, this expression here, x squared plus 1, the derivative of that is going to be 2x, which will then be able to cancel out that x. So u is x squared plus 1. du dx is 2x. So du over 2x is dx. So then this becomes 4 pi integral 0 square root 3 of x square root u du over 2x. That x cancels with that x. That 2 reduces that 4 and makes it a 2. So this is going to be 2 pi integral from 0 to square root 3 of u to the 1/2 du, which becomes 2 pi times u to the 3/2 times 2/3. U to the 3/2 divided by 3/2, which in other words is times 2/3. Okay, 0 to square root 3. And substitute back in for u, that's going to be 4/3 pi x squared plus 1 square root of x squared plus 1 cubed 0 to square root 3. Alright, and that's going to become 4/3 pi. It's going to be a little weird, isn't it? Square root of, if I plug in square root 3, it's going to be square root 3 squared plus 1 cubed minus, yeah, I don't have enough room. I hate not having enough room. I really, really loathe running out of room. Erase, doggone you. Okay, finally. Let me come this way with it. Alright, square root of 3 squared is 3. 3 plus 1 is 4. 4 cubed is 64. So 4 cubed is 64, but I got to take the square root of that, so then that's 8. Minus 0 squared is 0, plus 1 is 1. 1 cubed is 1. And the square root of 1 is 1. So I believe that gives me 7. And so that gives me 28 thirds pi as the answer. And I am hoping for that green check mark with that, but kind of scary, isn't it? 28 thirds pi. Come on, baby. 28 thirds pi. Yes, sir and ma'am. Alright. Next question. Number 5. If a force of 21 newtons stretches a spring 0.3 meters beyond its natural length, how much work does it take to stretch the spring 2.5 meters beyond its natural length? Okay, so I think the first thing I want to do here is figure out the spring constant for this spring. And we can do that because the force of the spring is basically equal to kx, basically. Maybe some signs we have to worry about, but don't worry about it for this example. So 21 newtons then, that's the force of the spring, stretches that thing 0.3 meters. So 0.3 is what x is, and I can solve for k that way. And that gives me 70 equals k. And so now the work done by a variable force, the work done by a force in general is force times distance. But if it's a variable force, it's the integral of force integrated over that distance. So in this case, the work done by the spring is equal to the integral of the spring force over that the x. And so in this case, it is the spring force is 70x, and that's over that distance that it does it. And so then it's going to go 2.5 meters beyond its natural length, so 0 to 2.5. So that gives me 70x squared over 2, which is 35x squared. It evaluated from 0 to 2.5, which is going to be 35 times 2.5 squared minus 35 times 0 squared. That goes to 0, so 35 times 2.5 squared, I get 218.75 or 218 3/4. Let's see if that is acceptable here. 218.75. That is correct. Awesome. Next. Alright, I believe this one is an integration by parts. Remember Lie8? I gotta snip this. Okay, Lie8. The acronym from Nancy Pie about choosing U and V. Logs, inverse, trig, algebra, trig, exponentials. So what do we see first here? We see an algebra and a trig. So the algebra is going to be the u. So u is x. So du is dx then. Alright, and dv is sine 5x. So if I integrate sine of 5x, v would be 1/5 negative 1/5, sorry, negative 1/5 cosine of 5x. Because if I take the derivative of that, the derivative of cosine is negative sine. It'd be negative 1/5. It would be negative 1/5 sine of 5x times 5, which would cancel out to 1/5, and you would end up with sine of 5x. Alright, and then it's integration by parts is uv minus the integral of v du. And I should have said, sorry, dv is sine 5x dx. I should have said that. So uv would be x times negative 1/5, and I'm going to put the negative 1/5 in front, cosine 5x minus the integral of v, so negative 1/5, I'm going to put that out front, cosine 5x du, which du is just dx. So I'm going to go ahead and make that be plus. Since it's minus and negative, I'm just going to make it plus. Alright, this integral right here is going to be sine of 5x times 1/5. Integral of cosine is sine, so sine of 5x times 1/5. And then you still got that 1/5 to multiply with it. So I get negative 1/5 x cosine 5x plus 1/25 sine 5x. And since this is an indefinite integral, I got to put plus c. Now let's hope this is right. I'm going to put the 1/25 sine 5x first, then minus 1/5 x cosine 5x. 1/25 sine 5x minus 1/5 x cosine 5x plus c. Now let me just bring this back up and make sure I typed it in right. 1/25 sine 5x minus 1/5 x cosine 5x plus c. Check answer. Green check mark. Next question. Alright, number 7. This is one some people said they had trouble with, and I can understand why. Alright, well, if we do liate again, the first one we actually encounter is the log. So we're going to let u be the log. U is ln 3x. It means du dx is 1 over 3x. 1 over 3x times 3 which is just 1 over x. So du so x du is dx. So du is dx over x. dv is 8x dx. So v is going to be 8x squared over 2, which is 4x squared. Okay, so now u times v. U times v will be ln 3x times 4x squared. I'm going to write it like this. 4x squared ln 3x. Alright, minus the integral of v, which is 4x squared. I'm going to put my 4 outside. Why is this not working? Where's my darn eraser? I can't get my eraser to work. So, I'm just going to keep going. Just mark this out. Well, okay, now my eraser decides to work. How strange is that? Alright, so I'm going to put my 4 right here. So V, that's 4x squared, put my 4 right there. Du is dx over x. So that cancels that, and it just becomes an x. So then this is 4x squared ln 3x minus 4x squared. This whole thing becomes 4x squared over 2, which then becomes 2x squared. So minus 2x squared. And we evaluate that from 1/3 to 5. So this becomes 4 times 25 times ln of 15 minus 2 minus 2 times 25 minus 4 times 1/9 ln of 1, because 3 times 1/3 is 1, minus 2 times 1/9. Now ln of 1 is 0, so that term goes away. So this then becomes 100 ln 15 minus 50 plus 2/9. So 100 ln 15. Alright, 50. What's 50 minus 2/9? That's 49 7/9. So it's going to be negative. So negative 49 7/9. Alright, let's type that in and see if that happens to be the answer. $100 ln 15 minus 49 7/9. Whew, got it. Yeah, I didn't like that one a whole lot. But moving on. Number 8. Alright. Okay, number 8 is it's just a little more complicated than what I would like for you to have on this test. So I'm going to remove number 8. I'm also going to remove any problems like number 8 from the test. So don't worry about number 8. Let's go on to number 9. Alright, for number 9, write out the first 4 terms of this series. That would mean plugging in 0. So if we plug in 0, we get 5 over 3 to the 0 plus 1 over 2 to the 0. That's like 5 over 1 plus 1 over 1, so 5 plus 1. So that narrows it down to C and D. But the next term is going to be plugging in 1, and it's not going to be 5 plus 1 times whatever's next. It's going to be 5 plus 1 plus whatever the next term is. So we can already go ahead and say that it is D. Now, let me split this up into 2 different sums. So, and then for this sum, I'm going to factor the 5 out front. So I can say it's 1 over 3 to the n. And this one I can write it as 1 over 2 to the n. So now both of these are now geometric series with r less than 1, which means we know that they converge. Okay, so, and the sum of a geometric series with r less than 1 is always going to be 1 over 1 minus r. So that should be easy to compute. This one right here is going to be 1 over 1 minus a third, which is 1 over 2/3, which is 3/2. So then we have 5 times 3/2 is 15/2. And that is the sum of this part. The sum of this part is 15/2. This one's going to be 1 over 1 minus a half, which is 1 over a half, which is 1 times 2, which is 2. So this one is 2. So now we add them together, 15/2 plus 2, and 2 is the same thing as 4/2. So 15/2 plus 4/2 is 19/2, and that is the answer to that problem. Alright, looking over number 10, working through it. Number 10 is also it's very complicated. It's a lot more complicated than a problem that I would want you to have on this test. So don't worry about number 10. It's going to be removed from the practice test, and any problems like it will also be removed from the test. That should do it for going over this practice test. Good luck with your studying and preparing for the test.